All right, in this video, we're going to go ahead and do 8.4, the determinant of a square matrix. We kind of saw a little bit of this in the previous subunit. We're going to go more into it for this chapter, or subchapter, I should say. So recall, that, again, this is from 8.3. I'm sorry, yes, 8.3. That the determinant of a matrix is basically this right here, A is equal to this, is given by this notation right here. So we have determinant of A. Okay, and there's a little bit of new notation, but it's going to be, it looks kind of like an absolute value, but it's two lines, and it's equal to these two multiplied minus these two multiplied. So we in the previous subunit we did A, B, C, D, so it was AD minus BC. We want to be more general here, so we're going to do A1, B2 minus A2, B1. So this is the determinant, this part right here. And we use that to find a multitude of things um, in the matrix world. I guess you could say that matrices have a lot of applications. So we'll get to that part of 8.5. Okay. So we're going to go ahead and just find the determinant for these couple of matrices here. And this is the easy part. The inverse is the one that required more steps where you had to use the determinant to find the inverse. Here we're just finding the determinant for these two. So let's go ahead and do that here. We're going to go ahead and do our little cross section here. So it's going to be these two. So 1 times -1 minus these two. So 3 times 2. And we just work it out. So 1 times -1 is -1 minus 3 times 2 is 6. So that's just going to give me -7. So that means that the determinant of A, which we notate like this, okay, is equal to -7. Or we can also say it this way, the determinant of A. Okay, easy as that. Let's try the next one, letter B. So same thing, we're going to go ahead and do our little cross section here. So 5 times 2 minus the other cross section, -4 times 0. Well, 5 times 2 is just 10. Anything times 0 is going to give us 0. Okay, if I put it in parentheses, it makes you more comfortable, which is just 10. So the determinant of B, which we can also notate with these two lines here, is equal to 10. All right, let's go ahead and look at the next example here. So 8.4 has a really interesting process, and basically it's a process to find determinants of matrices that are bigger than 2.2. So I kind of put that here in the corner to find determinants that are greater than 2 by 2s. We use these things called minors and cofactors. Okay, so there's a few things for you to write here. Go ahead and start copying that. It says if A is a square matrix, n by n, meaning same rows as the columns, then the minor, notated as m with the ijth entry, of the entry Aij is the determinant of the matrix obtained by deleting the ith row and jth column of A. The cofactor Cij of the entry is going to be this right here, okay? So this looks super complicated, I know, but basically all this means is that we're going to, once we find the minors, which I'm going to show you how to do in just a bit, um, we have to multiply them either by a negative or a positive, depending what entry they land on. An easier way to see this, and I did include this in your notes because I think it'll help, is to look at the sign pattern. So we'll use this in the example in just a bit. If it's a 3 by 3, you're going to think plus, minus, plus, and then just alternate from there. 4 by 4, you continue the pattern, but you add a column, right? And you add a row. So you just put another sign, but it's always going to be alternating. So you can see that for n by n columns, you just keep on adding columns and rows, making sure that you're alternating signs. Okay, and we're going to use these alternating signs once we find the minors. Why are we finding the minors? Well, for n by n matrices, the determinant is it's not as easy as the ones we just did. We need these they're called cofactors. We need these cofactors to find the value of the determinant. And like I said, I'll show you that in a bit. This one, like the previous section, I did go ahead and kind of do all the work first, only because it is pretty extensive. So let me go ahead and show you what we're going to be doing here. Okay, so for example 2, and the good news is there's only two, I think there's only 2 more examples in this video. We need to find all the minors and cofactors of this guy. And the reason we're going to find that for this matrix is because we need this one. So we need cofactors to find for the determinant. I guess I can write it out. So to find the determinants, oh, you can't see what I'm writing. To find the determinants of A, we need cofactors. But to find cofactors, we need minors. So to find cofactors, we need minors. So in other words, if we have to find the determinant, we're going to have to find the minors because this requires this, but this requires that. If that makes any sense. Okay. So we need to get all of our MIJs first, which are the minors. This stands for the minors. Okay. So we want to think something like the following. So here's our matrix, by the way. Here's the matrix we're looking at. It's a 3 by 3. Use a different color for that. Is a 3 by 3. So just keep that in mind because we are going to need our sign chart for that later. So we're thinking something like this, okay? What are all these values going to be for the minors? Now, minors are kind of interesting. It tells us on the other page to find a minor, we need to find the determinant of the matrix obtained by deleting the ith row and jth column of A. So that sounds confusing. I know it does. So I'm just going to, that's why I'm saying these ones, I'm just going to kind of show them to you how it works. Okay. So right here we have the same exact matrix as up here. I just recopied it. Okay. So you can put an arrow. And since this is M11, meaning it's in the first position, it's row 1, column 1, we're going to cross out row 1 and column 1, and we're going to obtain this little 2 by 2 right here. Okay, so what that does is, well, we know how to find the determinant of a 2 by 2, right? We just have to use our little formula that we've had on the other page. So M11 is going to be now this matrix, -1, 2, 0, 1. Okay, remember to pause as needed. And then we can go ahead and do our cross section. So -1 times 1 minus 0 times 2, which gives us -1. Okay, so that means that the minor for this position for row 1, column 1, M11, is equal to -1. Now, the bad thing about this is that, well, there are 9 positions, right? We have, if in a 3 by 3, we have 3 rows, 3 columns, so there's 9 little positions to fill if you think of it that way. That means we have to do this 9 times. Okay, so I did not do it 9 times, so no need to worry. I did do it a few times, so just to kind of put the point on what we're doing here. Okay, so for M12, now we're looking at row 1, and again, I'm getting the from here. So row 1, column 2, just look at the little numbers. We're going to go ahead and cross out. Again, here's the same exact matrix from the original. So this is matrix A. Okay, this is A. Don't get confused on where this is coming from. This is just A. We're going to cross out row 1 and column 2, and the numbers that are left over, that becomes our our mini matrix. So you can think of it that way, that we're going to use to find the determinant of. So 3 times 1 minus 4 times 2 gives me -5. So this is going to be our number that goes in that position in row 1, column 2. Okay, so I think I did this about 4 times just to kind of show you again the process. So let's go, we're going to go through them, and then from there I'll show you what the next step is. Because remember, these are just, I'm not sure why this is all crooked. These are just the minors. We still have to find the cofactors. That's another little process. So here's M13, same thing. We're going to cross out row 1, column 3. Here's our brand new little mini matrix. Write it out. Find the determinant. So multiply, multiply, subtract. Make sure you do it in order. So this one has to go first. Okay. And we get M13 is equal to 4. Okay, so far these are all the minors that we're finding. Okay. We do it again. I do recommend you copy these down. Okay, so if you need to pause, pause. So M21, which is going to be row 2, column 1. We're left with these 4 numbers. So there we go. Write them out, do our determinant. Okay, and we end up with M21 is equal to 2. I think I did it one more time. Yeah, one more. So I went ahead and did one more. M22 would be row 2, column 2. Okay, so these are our 4 numbers. Multiply 0 times 1 minus 4 times 1, which gives us -4. And this would be the minor for row 2, column 2. Okay, so I'm going to go ahead and continue this on the next page just so you can see where we're going with this. Just drop the pen. And here at the top, what I did is I just kind of gave you the rest of them. So continue in this pattern, okay, we get the following. We get all of our positions. So you can see, I think we went all the way up to, we did these right now. We did all of these. So you still have to do those by yourself. I mean, you don't have to, but for an assignment, you would have to do the rest by yourself. But it's the same process. So that's the first step. It's a really long step. Next, we're going to get all of ourCij's. So these are the cofactors. Okay, and oh, by the way, I forgot to mention these right here are the minors. So these are the minors, not the UTEP minors. They're just the minors for math. So the next step we're going to do is we're going to get the cofactors by using our 3x3 sine pattern. So here is a reminder of what that is. We did this on the previous page. So the sine pattern's down here. That's where I'm getting this from. Okay, so here is the 3x3. Let me move this up a little bit. Here is the 3x3 sine pattern. And to get the cofactors, all we really do is we take our our minors. Remember, these are the minors. We write them out, and we're going to combine them with these signs. So think of it like multiplication. I have seen some people do this where they write out the numbers and they just write these signs on top. So you could think of it like this. This is positive, this is negative, positive. I'm just copying the signs. So negative, positive, negative, positive, negative, positive. And you're multiplying that sign times this sign. Think of it like a 1 if you may. Okay, so let me get my pen. All right, so for the first C11, okay, we're going to get that from the first position. So positive times a negative is -1, right? For the second position, so now we're looking at this too. Well, we have a negative here, and it's positive, so negative times a positive is -2. Okay, positive, positive, so it's still positive. Negative, negative is going to give me +5. Positive, negative is going to give me -4. Negative, negative is positive. If you forgot, you can use that little, remember this from a long time ago? The little Dorito or pizza, or whatever you want to call it. Positive, positive is still positive. Negative and negative is positive. Sorry, I had a little brain fart there. Positive, negative is -6. So these right here are our cofactors. This is what we were trying to find. Well, we're trying to find both the minors and the cofactors, but this is what we're going to be using for the next part of this problem, which I'm going to show you in just a bit. Okay, so step 1, find the minors, doing that crossing out the row, column, and get the determinant from there. Step 2, find the cofactors by combining with the sign chart here, the sign pattern that we have. So what the heck is all this for anyway? Okay, so let's go ahead and jump over to this page now. We have, and I think this is the last part, so we're almost done, guys. So the determinant of a square matrix. Okay, if it's a square matrix that's 2 by 2 or greater, The determinant, remember that's what we were talking about to begin with, of A is going to be the sum, okay, this is important, the sum of the entries in any row or column. So you can pick any row, any column, and you're going to add them up multiplied by their respective cofactors. So this is what this kind of looks like. Basically, if you chose, for example, row 1, okay, well that would be A11, A12, A13, all the way to A1n, right? Because if you remember, you don't have to write this part down, but it's A11, A21, A31, etc. This is A21, and so forth. Okay, so in this case right here, in this example, they're using the first row. So what we're going to do is we're going to take those entries and we're going to multiply them by the cofactors that go with them. So all of these are the cofactors that we just found. Okay, this process is called expanding by cofactors, and it is used to find the determinant. A special note here, notice that we only have to do one row, right? So if that's the case, that kind of helps you a little bit with the whole um, find the work on the other part. So for what I mean by that is, if we were going to use, let's say over here, if we were absolutely positive we were going to be using row 1, then really I only have to worry about those 3 cofactors. Does that make sense? So just some food for thought there. And if you want to do it all, by all means, you can always do it all, but just, trying to lessen the work here. So continuing from example 2, okay, this is the same matrix. We're going to find the determinant of A, and we are going to use the exact same pattern that we see up here. We're going to use row 1. So I guess I could use page. So we are going to use row 1. Okay, so for row 1, that's going to be this right here. My A11 is 0. My A21 is 2. Okay, I'm sorry, A12. What am I saying? A12. And then A row 1, column 3 is 1. Okay, so that means I'm going to use the cofactors. We're going to use row 1. So this means we need cofactors C11, C12, and C13. Basically the ones that are on the top also. Okay, so again, these are coming from this page right there. So let's go ahead and write all this out. We're going to have our determinant A is equal to A11, C11 plus A12, C12 plus A13, C13. And that's all we have to do because this is a 3 by 3. So we really can't, we're not going to add anything else to that. So let's go ahead and plug all this. Okay, so we're just going to go ahead and plug these in. So A11 is 0. C11 was -1. And this is just, remember these guys are from the previous page over here. So they're right there, first row. Okay. Plus A12, sorry, I had to wipe this out because I put the wrong number by accident right now. A12 is 2, so 2 times C12 is 5, A13 is 1, and C13 is 4. Okay, then we just simplify it. This is going to give me 0 plus 10 plus 4. 0 plus 10 plus 4 is equal to 14. So the determinant of A, which we can also notate like this, is equal to 14. And we're done. That's it, guys. If you have any questions, let me know.